Welcome back to another episode of the ContinuousX podcast, where we tried to solve for X in the SDLC equation. We're back with Cliff Berg, co-author of Agile 2, the Next Iteration of Agile. And Cliff, I want to, let's discuss the challenges within the public sector. The adoption of Agile is the contractual obligation in labor court categories, where traditional Agile methodologies prescribe everyone's more generalist role in many ways, doesn't really add up to actual what's happening in a development community and creating services and creating workable projects. How can Agile 2 help address these challenges in the public sector?
Well, thanks, Rick. The whole, the Agile community has moderated a little bit the whole generalist, idea. The kind of paradigm today is T-shaped, but we have to differentiate based on what we're working on.
Right.
If we're building a little website that sells jam and jelly, yeah, fine. Get a bunch of people together and everyone's T-shaped and they all kind of do everything. That's great, but, if you're building, say, machinery that has electronic control units in it that send telemetry, what?
Weapon system, yeah.
Yeah, or weapon systems that, is communicating in real time.
I'm normally a UI guy, but I'll do the weapon system.
So number one, those stacks are too deep. Number two, there are usually several different vendors doing different parts of it for a number of reasons. It's a whole different situation. And you can't apply lessons from one to the other necessarily. You have to use judgment. The situation always matters. In the kind of website world, it's usually about features. But with machinery or weapon systems and that sphere, it's more about capabilities. You want to have the capability to do this and the capability. And so, when you're developing, you have to demonstrate the capability, and then you have to refine that and make it reliable and everything. So, so the way that you plan that work is different. The capabilities might be a stretch. You might have to prove that you actually can do it. So the whole, risk-based approach where you're trying to develop the critical capabilities early is really important. And you need specialists. Programming is a little bit different in that anyone can learn it on their own. It's not like becoming an engineer where, there are people who can learn engineering on their own, but they're pretty rare. Mm-hmm. Engineering requires, a lot of mathematics. Engineering starts with calculus. Mm-hmm. It doesn't end with it. It starts with calculus. And builds on that as multiple layers of mathematics and different techniques, and depending on the kind of engineering. And you have to learn thermodynamics and all kinds of things. That's not something you can just transfer to someone by coaching them. You need experts. And sometimes they have PhDs. If you're building an advanced machine learning system, you need people with PhDs. If you're using commodity machine learning that you pull down from Amazon or something, yeah, anyone can do that, any programmer. But that's not the state of the art stuff. That's for simple things. Right. If you're building something that's going to recognize targets in real time on something that's running on hardware that's in flight, that's customized machine learning models.
Right.
And you need people with PhDs for that. And so the question is, how do you interface teams of experts with teams who are building other things? who have other, like people who are building application software. So like if you have a distributed system with real-time components that's sending telemetry, then there's probably a data pipeline that's analyzing that using Spark or similar kinds of parallel processing things.
Yep.
And then that probably feeds a command and control system or something, So, and there's analytics operating on that. So there are regular applications being built, So programmers can do that. But then the embedded software requires people who know real-time programming in languages like C and so on.
Right.
It's different, So coordinating all of this, the old approach is to task it out, to try and design ahead of time all the pieces and then task it out. But the challenge with that is that it's all uncertain, because unlike building a bridge, all these pieces, none of the people on the team have ever built them before.
Right.
They're all unique. You never build the same software twice.
True.
So how can you task it out? You really can't. There are steps you can task out. And there are intersection points where you know that to demonstrate this capability, we need another capability. And so there's a dependence. And so you can create milestones. But below that level, you can't really task things out. For the most part, it depends. Some things you can and some things you can't. Usually the coding parts, the software parts, you can't task out. So because that's not how coding works. It's not task-based. It's a creative thing. You don't know what it's going to end up looking like. Imagine a building that has 1,000 floors, and any floor can open a door and connect to any other floor. And that's software. Yeah. Good luck designing that ahead of time.
Interesting.
Yeah. Imagine a spreadsheet that has 1,000 pages with formulas all over it. And the pages have formulas that are interlinking to formulas on other pages. Try to design that all ahead of time.
Try to let that load.
Yeah, right. It has to evolve. People cannot figure it out ahead of time. They can figure out kind of the big pieces, but they can't see all the interconnections ahead of time. They can't anticipate every interconnection, every dependency, every way it's going to be structured. It has to evolve, because as you're building it, you suddenly see more clarity, and then you realize, this has to connect to this here. I actually need an extra piece here. And so the evolved refines. The original computer science term for that from back in the 60s is refinement. Mm-hmm. That the design refines over time. Mm-hmm. And so, so we need to allow it to evolve, but we also need to coordinate people who are working in different parts. Like, say there's a machine learning team, and someone in a leadership role has to have enough understanding of machine learning stuff, and also how the application team stuff is working. Someone has to understand both, not at a real detailed level, but at a working level, in order to be able to bridge them and initiate a discussion between that team and the other teams to say, how are we going to feed work from you to you, and how are we going to feed outcomes back to you? And what's that going to look like? You can't do it administratively. You have to roll your sleeves up and ask hard questions and understand. You have to develop an understanding of the flow of information and what people need to know, when it makes sense for tests to be run. You have to be in there with the conversation and follow the conversation in order to be facilitating that kind of discussion. So we need leaders who are leadership there. We call it participative leadership. We need people who, instead of trying to lead by tasks, they lead by asking questions, like Mark Schwartz, you mentioned. Asking questions. How does that work? Explain that to me. I don't really get it, so I'm going to go read a book, or I'm going to get an expert and have them tutor me in it for a week. Right. And I'm going to learn enough about that so I can follow these conversations to help you guys figure out how to connect this team to that team so the work is fluid and ongoing and no one's ever waiting for anyone.
And that's very difficult in any organization, but in the public sector, as you know, and Mike and I know very well, that you don't get these experimental awards. You get awards based on your past performance, doing something in that category, in that context, so that you can demonstrate that you're not going to waste money. That's a very different paradigm shift from what the goal of Agile 2 is, and even DevOps, DevSecOps, because it is a learning process. It's organic. It keeps growing. It keeps feeding upon itself. But how do you put procurements out there, opportunities out there that say, we're going to pay you to learn about our business? It's antithetical to the way that they approach procurements. So do you have any advice as to how maybe even public sector agencies can design or ask the right question for the industry to respond in a manner that would be, compliant and governed?
Well, I think we need to get ourselves unaddicted to the notion that you can issue a bunch of requirements and then have someone deliver a complete solution meeting all those requirements. That's kind of based on the financial management paradigm of, an organization is a static entity, and that in order to change something, you create a project and it has an ROI, and then you put funds into that, and then it creates a change. And now there's a new steady state. And that whole approach is obsolete because, it's the world now, things are too dynamic. It's like in the commercial field, you can't create a piece of software and then just run it.
Right.
It's obsolete like a week later. So differentiating between maintenance and improvement is useless. It doesn't make sense anymore to separate your budget into maintenance and improvement.
Right.
Because if you separate it like that, you remove the tactical flexibility that product managers need to be able to respond to changes in the market. They have to be able to say, well, yeah, we're maintaining that, but actually we're going to just scratch that feature altogether and replace it with this new one. And they need to be able to make those decisions day by day, not plan it a year ahead of time.
Right.
So let's stop differentiating between maintenance and improvement. When you create a capability, especially with software, it's a living thing. It's like giving birth to an animal.
Yes.
And it's continuously growing. And, you're continuously improving it. And it should start with a demonstration of life, a demonstration of capability. And that's a success. That's a measurable success. Mm-hmm. In a business context, you would use a lean financing approach where, instead of constructing an ROI for a fixed set of features, you would have a lean investment experiment where there's someone makes an argument that if we build this thing, users will come and they will buy it. They'll like it. Okay, so you try that, it works. Okay, so we're still not making money, but at least our hypothesis is true. Mm-hmm. The next step is prove we can make money from it. So scale that up. Let's see if we can do that. We're making money. So now our spend rate is profitable. Our spend rate. So it's not a fixed amount. It's an annual spend rate. And we're going to keep spending as long as it's profitable. And, over time, things change. We might want to increase spending or decrease spending depending on our overall amount of funds and other opportunities. But our spend continues. And at some point, if it becomes less profitable, we decrease our spend rate, and it becomes unprofitable, we sunset it.
Right.
It becomes an off-ramp. And so, this whole idea that you can have a fixed investment and get a fixed system and then later on plan for improvements, that's obsolete. We need to think about, growing capabilities. And, once it's there, you have to keep feeding it.
Yeah.
It's not just about maintenance. Feeding includes helping it grow. It's a paradigm shift. It is.
And bringing it back to the public sector, agencies need to realize when a capability or an application or a service is no longer needed. There are so many instances that I could off the top of my head where agencies are trying to do, migration to the cloud, and they don't even know how many applications or workloads they're even running right now and maintaining. Imagine the amount of resources wasted in keeping the lights on something that's not being used. So I agree with you. Treat it as a living organism, and sometimes those organisms die. You got to get rid of them.
Yeah, I mean, a lot of times there's end user computing that's going on that you don't know about. There has to be a visible portfolio of where the money's going, and so that you can manage that overall portfolio. But it really needs to be managed at a capability level, not a system level, a system with fixed requirements. It needs to be, and seen as, ongoing spend for that capability. Yes. If you view it as a capability, yeah, we want that capability. If you view it as a system, then it's like, okay, well, we have that system. Let's stop spending. Yeah. But then it will die.
Right.
And it will die. No, it's a capability, and it's costing this much per year to maintain that capability and keep it growing, keep it effective.
And even if it's not growing, just security alone, there's always new security threats that need to keep that thing alive. It just does not thrive on its
healthy,
own.
Hygienic.
Hygienic, yeah.
Right. Yeah.
Big time. Constant, with, their new vulnerabilities, open source stuff, and new versions break things all the time. And there's an increasing trend in the industry to not maintain backward compatibility, for APIs and tools. Fair. It's really dysfunctional. I like the Java ecosystem put a very high value on backward compatibility, but a lot of other ecosystems don't. I teach a DevOps course, and I'm constantly finding new versions like break things that used to work. And so now it's with the test. A lot of the test tools do this. Mm-hmm. And a lot of the test tools are not backward compatible, and suddenly stuff doesn't work anymore, and you have to invest a lot of effort to make it work again when it used to work. Right. It's a waste of people's time, in my opinion.
Well, Cliff, it has been a pleasure over these last couple of episodes. A fountain of knowledge, and we can go on and on and on. So I really appreciate your time. I appreciate the listeners' time. Looking at this, we're going to have many different topics with Cliff in the future. So thank you very much for your time as we solve for X in the SDLC equation.
Thank you.